Here you have a topic called permutation and combination. This permutation talking about arrangement of numbers, and then combination is talking about selections. But let's look at this one first. So what is it about permutation? So you're talking about arrangement of numbers or of objects. Like you have six people sitting in a chair. So if you have maybe this is bench, so you have maybe this bench can contain like six people. So permutation is talking about in how many ways can these people sit on this particular chair. So that's what it's talking about. In how many ways can they do it? So like if you have ABC, one ABC, in how many ways this object can be arranged? So you can have it as ABC, you can have it as ACB, you can have it as BAC, you can have it as what? BCA, you can have it as CAB, and you can have it as what? CBA. So what are you seeing? How many ways are you seeing here? You are seeing 6 ways. So that is it about permutation. So what I'm saying here is that how many ways can this number be, can this object that is ABC be arranged? So you can arrange it like this, like this, like this. So if you count it now, it's 6 ways. So there come what we refer to as factorials. So in how many ways can they be arranged? Here is factorial. So that will be what? 3 times. So your answer simply will be 3 times 2 times what? Times 1. So 3 times 2 times 1 is meaning of 3 factorial. So that's, if you multiply this one together, you will get 6. So if it is 4 objects also, the same thing you are going to get. Here you have 4 factorials. So your 4 factorial is going to be 4 times 3 times 2 times 1. So if you multiply this one together, you will have 24. So that's so that if it is 4 objects, the number of ways you can do is going to be 24. So that is it. So you have a straight line arrangement like that. So like sitting on the bench, and you have it like that. Like bead. Bead can be in a row, can be in what? A row, or it can be in circular. And sitting can equally be in a row, or it can be in circular. Then that's why I want to talk to you about the second part. So here, so this one has different parts. Here you have a circular sitting, like sitting around the table. So if you want to sit around the table, here you have this. Let's say you have 5 people here that they want to sit around the table. So as in how many ways can they sit on this circular part, on this circular table? Now the assumption is that circle is what? Is infinity. Circle is what? Infinity. That is, if you are going like this, you can just be going like that. It has no end, beginning or end. So in how many ways are you going to arrange it? The assumption is that you have to fix one. So where you are going to stand. So here, you can fix a particular person here, so you know how you are going to arrange the rest. So, because when you are coming like this, you know that one starts from here. So you will not cross to this place as you are counting. So here, in circular arrangements, as you have that one, say if it is any arrangement, you can represent it with n factorial. The n factorial represents any number. 3, in how many ways 3 people can be arranged? Sit in a table, in a chair, bench, or whatever. 10, 20. So the n represents the number. So here you have circular. In the case of circular arrangement, it's not like that. In the case of circular arrangement, you have n minus 1 factorial, then times 1 factorial. How is it like this? It's like this because what you have here is circular. So you fixed 1. This one you fixed is the total number now minus 1 because 1 is fixed already. Then and how many ways 1 can be arranged is 1. So you can put it there as 1 factorial because you fixed it. You fixed 1. So in order for you to be able to count it. So that's it. So that's what it means. So you can look at this example. There are some conditions that are there. There are some other aspects we will go to that. There are some things that can add that they can attach to it because in your exam, like JAM or WAEC, you may not see it directly like that. So look at this particular question, like in how many ways can 7 people sit on a bench? Now, let me put it like this. One, if they can sit anywhere. So here is that they can sit anywhere. Two, if the if two people if two people must occupy the first seat. So that's another one. So look at this one also. Three, if two people must sit together. So let's have this one more. If two people must not sit together. Isn't it? So let me stop here. Look at this. Now, let's say you have, so what you have here is 7 people. 1, 2, 3, 4, 5, 6, 7. So this is what they are going to, this is the number of seats that are on the bench. So in how many ways can 7 people sit on the bench? If they can sit anywhere. So when they tell you that they can sit anywhere, it simply means that's 7 factorial. So they are just as the formula n factorial. So that's it. Here is the number of ways they can sit anywhere. So forget factorial is in your calculator. If you want to press you look for it there, like quotation mark. So here you have, here is 7 factorial. So 7 factorial here is what? 50. No, see. So that's it. That 7 people can sit, if they can sit anywhere. That's it. So you can have them like that. Look at another one. If 2 people must occupy the first seat. So look at this one. What happens is 2 people must occupy the first seat. This is the first seat. Now, this one, they simply tell you that 2 people will occupy the first seat. So they didn't tell you that maybe the first will occupy it, the second will occupy the second row. But they just tell you that 2 people must occupy the first seat. What happens is that in the second one, this one, the second one is going to be the 2 people that occupy the first seat, because one can sit here, another one can sit here. If it's husband and wife, if or maybe a executive, the president and the vice president, whosoever that comes first. Maybe if it is based on whosoever that comes first, so A can sit here, B can sit here, or B can sit here, A can sit here. So it can still be arranged, except they instruct you that president and vice president must sit in the first and second seat in that order. So the solution is going to be different. Now, so what you have here is You have arranged this one. So what now remain? It remain 5. So you have 5 times what? 5 factorial. Because this one also, you can arrange them within themselves. So that's it. So what is going to be your answer? Is going to be 240. So that is 5 factorial multiplied by 2. So you have it as 240. 3. If two people must occupy 3. If two people must sit together. Now look at the difference between this one and this one. Here they say that two people must occupy the first seat. So that's what it says. But here they say two people must sit together. They don't tell you whether they are going to occupy the first seat, the middle seat, or the last seat. Only that they must sit together. So how are you going to do that? So look at it. What happens is the two people, since they are going to be together, they can sit anywhere also. Only that they must sit together. They can be here, 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 anywhere. So only that two people must sit together. So the two people that must be together, because if this is the two people can be here, 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 here. So they can still be arranged within themselves. So this one is equally subject to arrangement. So you count them 1, 2, 3, 4, 5, 6. So this one is 6 factorial. Then the two people also can be arranged within themselves because A can sit here, B can sit here, or B can sit here. So you have 2 factorial. So I want to understand the difference between the two. If they tell you that the two people must sit together, maybe one will occupy the first, and anyway, so you know how you are going to solve it. So your answer is going to be this. So here you will have 6 factorial, 720 times 2. So you will have 1440 wins. So that's it. Then 4. They say that if two people must not sit together. Now, here, they say that if two people must not sit together. So if you want to solve this, how are you going to do it? Is since two people cannot sit together, now this the ways if they can sit together, this is it. That they cannot sit together. So how you solve it is that they can sit anywhere. That is, if two people must not sit together. So how you are going to solve it is that they can sit anywhere, minus they can sit together. So that's it. So they can sit anywhere, minus they can sit together. So here you see that they can sit together. I mean they can sit anywhere. That's 7 factorial minus they cannot sit they can sit together. Here is they can sit anywhere, minus they can sit together. So here you have it as 6 factorial times 2 factorial. So that's it. Now look, you can solve this one like this: 7 factorial minus 6 factorial times 2. 2 times 1 is 2. 2 times 1 is 2. So here you can have 6 times 7 times 6 factorial. So you bring it down a bit. You can do it 7 times 6 times 5 times 4 times 3 times 2. But just bring it down a bit. So what you have here is 6 factorial times what? 2 factorial. So what you have here is 6 factorial into bracket 7 minus 2. So you will have 6 factorial times 5. Look, Sometimes they may not give you raw answer like this. It will be how this is how they are going to present it to you. So that's why it's good for you to know how to solve it like this. So, and if you want to get the answer now, so you will have so you will have 6 factorial, that's times 5, that's 3,600 ways. So that's it. So there are other aspects, but just look at this. So anyway, you can frame it. So you can. So thanks for watching. If you have any question there that's bothering your mind that you want to solve, you can put it in the comment box, or anything you want us to help you to solve, you can put it there. And then like it and share it. So you can subscribe to my YouTube channel. Thank you.